There is a place on this planet harder to reach than an orbital space station. We have sent rovers across the surface of Mars. We have captured images of black holes on the far side of the universe. And yet less than 5% of our own ocean has ever been surveyed. Far out in the western Pacific, near the Mariana Islands, a curved scar runs through the seafloor for roughly 2,500 kilometers. This is the point where one tectonic plate is slowly forced beneath another, sinking by mere centimeters each year, in a process that has never paused. Even now, at this very moment, it is still carving the trench deeper. Lower Mount Everest into it, and its peak would vanish under another 2 kilometers of water. The pressure down there could crush a nuclear submarine's hull as easily as an empty can. The temperature hovers just above freezing, and sunlight dies out long before it ever reaches those depths. Past 1,000 meters, an unbroken night begins. The only light comes from scattered flickers of bioluminescent creatures, brief sparks that flare and vanish back into the dark. The first human eyes to witness that abyss belonged to a Swiss oceanographer and an American naval officer. In 1960, they rowed a bathyscaphe down to the trench floor and spent roughly 20 minutes there. Their viewport had cracked during descent, leaving them little to see beyond murky water and a featureless plain of sediment. And yet the achievement itself remains staggering. 2 men reached the deepest point on Earth a full year before anyone reached orbit. After that dive, no human returned to the bottom of the trench for more than 50 years. Until 2012, when a filmmaker famous for chronicling a sunken ocean liner and an alien world descended alone in a specially built submersible. This time, not for a film, but purely for science. He spent nearly 3 hours down there in complete solitude, and what struck him first wasn't monsters or dramatic scenery, but an almost unbearable silence. No currents, no motion of any kind. Just a soft, gray-yellow sediment stretching out like a landscape borrowed from the moon. When that sediment was finally brought to the surface and placed under a microscope, marine biologists were left speechless. The mud was teeming with life. Thousands of organisms in every cubic centimeter, many unlike anything cataloged in the history of biology. Among them were single-celled giants the size of a clenched fist. Xenophyophores, essentially amoebas large enough to hold in your palm. Each one builds a fragile shell from grains of sand cemented together with its own secretions, thriving in conditions that would instantly destroy any familiar animal. But the true shock came when Japanese marine researchers found something else entirely in the sediment. Bacteria that consumed hydrocarbons outright, feeding on oil-based compounds. They didn't merely survive the crushing environment. They actively multiplied, quietly processing organic material that had been drifting down to them for millions of years. The discovery immediately spawned bold interpretations online. Some claimed it proved oil forms deep within the mantle rather than from ancient organisms, offering up these bacteria as living evidence. Others went further still, suggesting that life on Earth hadn't originated near the surface at all, but in trenches exactly like this one, making us, by extension, distant descendants of creatures that once crawled out of such an abyss. Believers in extraterrestrial origins pointed to how closely trench conditions resembled the frozen ocean beneath the ice of Jupiter's moon Europa, arguing these microbes might share ancestry with organisms delivered to Earth by meteorites billions of years ago. The actual explanation turned out to be quieter, though no less remarkable. These extremophile bacteria had restructured their own cell membranes, making the fats within them simultaneously denser and more flexible, comparable to forging a metal spring that is somehow both rigid and elastic at once. As for the hydrocarbons themselves, they weren't rising from the mantle at all. They were the remains of organic material breaking down after drifting downward for weeks as marine snow. A ceaseless rain of dead plankton, waste particles, and organic debris sinking endlessly into the dark. Far more significant was another fact. The genetic code of these organisms has barely changed in 3 billion years. They outlasted all 5 of Earth's mass extinctions, every ice age, and the asteroid that ended the reign of the dinosaurs, simply because the catastrophes that scoured the surface never reached this far down. The trench turned out to be not a dead zone, but a living archive of evolution, a vault of genetic memory that scientists have only just begun to read. While biologists were still absorbing that discovery, another team encountered a mystery of an entirely different kind, one concerning not life, but water. In 2018, Seismologists from the University of Washington deployed 19 underwater instruments around the trench and spent a year recording how seismic waves from earthquakes traveled through the oceanic crust. Their logic was straightforward. Water trapped in rock slows seismic waves down, so measuring that delay reveals how much moisture the crust actually holds. What they found was startling. In the zone where the Pacific Plate dives beneath the Philippine Plate, the crust was absorbing water at a rate 4.5 times higher than every previous estimate. Each year, a volume of water comparable to an entire system of the world's largest freshwater lakes is drawn down into the mantle through this single trench, pulled inward along with the sinking plate and locked into mineral structures as deep as 30 kilometers beneath the seafloor. The moment this finding spread, speculation followed close behind. Some framed it as proof the planet was slowly swallowing its own oceans, warning that within 100 million years the seas could run dry. Others tied it to flood myths shared across dozens of ancient cultures, suggesting the mantle had once released stored water back onto the surface in a catastrophic deluge, turning old legends into distant geological memory. A few even proposed a hidden ocean beneath the crust, home to an unknown civilization, accusing governments of concealing what they knew about it. Geologists offered a calmer resolution. Water pulled into the mantle doesn't vanish forever. Much of it eventually returns through volcanic eruptions, carried back to the surface as vapor alongside ash and lava, part of a slow, planet-spanning cycle that has operated for billions of years and helped shape Earth into the world we recognize. What genuinely concerns researchers is the imbalance. If water is being drawn downward faster than volcanoes are returning it, then sea level, long attributed mainly to melting ice and rising air temperatures, may also depend on deep planetary processes we still can't measure precisely and haven't yet built into our climate models. If the trench's geology forces us to reconsider the planet's water cycle, its acoustics raise a question science still can't fully answer. In 2016, researchers from Oregon State University lowered a hydrophone, built to withstand 1,000 atmospheres of pressure, into the trench, expecting near total silence at 11 kilometers down. Instead, it recorded a constant chorus, the deep groan of shifting tectonic plates, distant rumbles of underwater earthquakes, the mechanical hum of ship engines passing far overhead, and even whale song traveling down through kilometers of water. The trench behaved less like a silent tomb and more like a vast acoustic basin, gathering and amplifying sound from across the entire Pacific. Buried within that noise, though, was a signal researchers couldn't identify, a low-frequency call lasting 2 to 3 seconds, starting on a deep note before sweeping sharply upward and ending in a metallic rattle. It repeated with unsettling regularity, powerful enough to register on their instruments for months. Online, it was quickly likened to the call of a mythical sea monster, compared to accounts of a legendary deep-sea leviathan, and linked to a similarly mysterious ultra-low frequency sound recorded in 1997 and once attributed to some undiscovered creature the size of a small town. Given how little of the deep ocean we've actually explored, the idea that something enormous and unseen might be responsible felt entirely plausible to many. Oceanographers eventually proposed a far less dramatic source, a minke whale, whose known calls match the signal's frequency pattern almost exactly. Yet one detail keeps the case from closing. Minke whales typically vocalize this way only during their breeding season, while this sound was recorded year-round, with no seasonal gap at all, leaving researchers with a mystery that fits no existing behavioral model. Sounds, at least, can be recorded and endlessly reanalyzed. The next discovery in the trench concerns something that, by any measure, simply shouldn't have been there. In 2019, an American investor and explorer completed a record-breaking solo dive to the very bottom of the Challenger Deep, descending in a titanium-hulled submersible he had personally funded and helped design to withstand pressure at any depth in the global ocean. Cameras captured translucent shrimp-like amphipods and sea cucumbers drifting slowly across the sediment at the bottom of the world. Footage that delighted him, until something else appeared in frame that turned his excitement into disappointment. A plastic shopping bag resting on the floor of the deepest place on the planet, alongside candy wrappers and an unidentified scrap of packaging. Later analysis of sediment samples confirmed the worst suspicion. Microplastic particles were found inside the tiny amphipods living down there. Creatures that have never seen sunlight and endure pressure capable of crushing a submarine, already carrying human waste inside their bodies. It was one thing to find plastic on beaches or inside sea turtles. It was something else entirely to find it 11 kilometers down, in a place fewer than a handful of people in history had ever reached. It confirmed that no location on Earth, however remote or inaccessible, remains untouched by human activity. Not the summit of Everest, not the ice of Antarctica, not the floor of the Mariana Trench. Scientists soon worked out how plastic manages to travel that far down at all, since it should, in theory, simply float. The answer was unsettling in its simplicity. Sunlight and wave action slowly break plastic apart into ever smaller fragments, which then become coated in colonies of bacteria and algae, growing heavier than water until they finally begin to sink, joining the same steady rain of marine snow that carries dead organic matter to the depths. Researchers from the Chinese Academy of Sciences later measured microplastic concentrations in the trench's sediment and found them higher than in some coastal waters of Asia. The trench effectively functions as a giant funnel, with deep currents gathering lightweight debris from across the Pacific and channeling it toward the one place it can never escape. And because there is no ultraviolet light to break it down further, no strong current to sweep it away, and almost no organisms capable of processing it, that plastic is likely to remain on the trench floor for centuries, if not millennia. A mark left in a place we never intended to reach, and one we now have no way of erasing. The final discovery concerns not what has been found at the bottom of the trench, but what the trench itself is doing to the planet, right now, in real time. Unlike plastic pollution, this force existed long before humanity and will continue long after us. In recent years, seismologists have noticed unusual activity along the fault. Earthquakes here are constant. This is one of the most tectonically active regions on the planet, a segment of the horseshoe-shaped ring of volcanoes and fault lines encircling the entire Pacific Basin. But the character of these earthquakes has begun to shift, so-called slow earthquakes, in which plates move not in a sudden jolt, but gradually, over days or even weeks, releasing enormous energy without ever triggering a tsunami or making headlines. These events have become noticeably more frequent. Researchers from Japan's Marine Science Agency discovered that the Pacific Plate in this region isn't behaving the way standard geological models predict. Rather than sliding smoothly beneath its neighbor, it is fracturing outright. In 2012, a powerful earthquake struck 600 kilometers below the surface. An anomaly in itself, since rock at that depth is under such extreme pressure it should flow like thick syrup rather than snap like glass. Yet it broke, with a magnitude of 7.6. More than enough to level a city had it occurred near the surface. Some corners of the internet linked the event to secret geophysical weapons or to theories of a hollow Earth hiding an inner world of its own. Geophysicists, working from actual data, arrived at an explanation that is arguably just as extraordinary. The sinking plate carries water locked inside mineral structures such as serpentine, and as pressure and heat increase at depth, that water is squeezed out into what's known as a supercritical fluid, neither fully liquid nor fully gas, which weakens the surrounding rock from within, much like an acid working through metal. The plate doesn't break because something strikes it from outside. It breaks because water is dismantling it from the inside. This brings the story full circle. The same water being dragged into the mantle through this trench doesn't simply disappear. It actively reshapes the mechanical behavior of rock at extraordinary depths, triggers earthquakes far below where they should be possible, and influences volcanic activity across an entire region stretching from Indonesia to Japan. Every eruption, every tremor along that arc traces back, in part, to this single narrow fracture in the Pacific floor. The trench isn't merely a crack in the seabed. It functions as a vast geological mechanism, pulling water inward, fracturing stone, and eventually returning both, through distant volcanoes, thousands of kilometers from where the cycle began. We live on a thin shell above a process that never stops, and this is one of the few places on the planet where that process becomes visible. We've now traveled 11 kilometers down, past the point where light disappears, where warmth disappears, and where most of our assumptions about how the world works disappear along with them. We followed a thread from bacteria older than the dinosaurs to plastic bags that will likely outlast our entire civilization, and every discovery along the way turned out to raise more questions than it answered. This trench holds up an uncomfortable mirror. It shows us both the sheer scale of nature's resilience and the sheer scale of our own carelessness. We found life that has persisted for 3 billion years without sunlight or oxygen, forcing us to reconsider what we even mean by the word life. We learned that the planet is quietly drinking its own oceans and returning them through volcanoes in a cycle as old as Earth itself, one that undermines the assumptions built into our climate forecasts. We recorded sounds we still can't fully explain, a reminder that even in an age of satellites and supercomputers, the ocean guards its secrets more tightly than any vault. And we confirmed that even the most inaccessible place on the planet already bears the fingerprint of our presence. Perhaps the most sobering discovery of all. Perhaps that is the real lesson this place offers. The planet is not a backdrop for human affairs, but a living, breathing system that runs by its own rules, entirely indifferent to whether we understand them or not. The ocean isn't waiting to be understood. It simply exists, deep, dark, patient, and endlessly capable of surprise. And if we ever hope to understand its rules, we will have to stop trying to conquer the depths and learn instead to listen to them.